Hi students, this is Mr. Yao. In today's lesson, we are going to talk about the last lesson in Unit 6, which is called Sequence in Context. We are going to apply the sequence we have learned in context. Example 1. Sarah is preparing for a hot dog eating challenge. On the first day of training, she eats 5 hot dogs, on the second, 8 hot dogs, and on the third, 11. Assume this pattern continues. So when we are trying to form a sequence, we are basically trying to look for a sub 1, a sub 2, a sub 3, etc. And then we can actually use that for the pattern. So of course, we're going to need some kind of information that provide us with 1, 2, and 3. And in this question, it does. First day, second day, and third day. So that means our first day is basically our a sub 1, which is 5. Our second day is basically our a sub 2, which is 8. And a sub 3 is the third day, which is 11. Now we can use that and continues. Now we can use that to find a pattern. 5 to 8 is adding 3, 8 to 11 is adding 3. And that means it's got to be a common difference. Sequence type is arithmetic, and the function is linear. So this part, the middle part is basically things we have learned. Just now this time, we are going to need to generate the sequence from the words by ourselves. Recursive formula, a sub 1 is 5. And a sub n equals a sub n minus 1 plus 3, because d is our plus 3 in the middle. Explicit formula, a sub n equals 5 plus n minus 1 times 3, which is 5 plus 3n minus 3. Simplify everything, a sub n equals 3n plus 2. And last question, how many hot dogs will she eat on day 17? First, you got to understand, we are talking about sequence. So you got to use sequence notation. You are going to need to express day 17 in sequence notation, which is actually looking for a sub 17. So I can just plug in n, because that is our n, that is the index. 3 times 17 plus 2, which is 53. And don't forget a unit, which is hot dogs. That's example 1. Should be fairly straightforward. Example 2 is very similar. So you're seeing it has the prospector was out mining one day when he hit an ore. And after a day, it weighs 500 milligrams. That's why it's a sub 1 equals 500. It has a half-life of 1 day, which means that the amount of ore reduced by half each day. Let's form the sequence. A sub 1 is 500, which is given. Then it's going to go half, is called half-life. A sub 2 is going to be 250, because that's basically day 2. And then we keep going, a sub 3 is 125, and a sub 4 is 62.5. Then keep on going. Pattern type, of course, since we're dividing by 2 or multiplying by 1/2, that is our R, so it's common ratio, geometric, and exponential function. Recursive formula, a sub 1, don't forget to list that, and a sub n equals a sub n minus 1 times 1/2. Explicit formula, a sub n equals 500 times 1/2 inside parentheses 2d n minus 1 power. Will it be better for the prospector to sell the materials on day 2 for $5 per milligram or on day 4 for $25 per milligram? Well, if you haven't noticed, all of these information, all of the numbers in the sequence we got, they're actually milligrams. That's the weight of the ore, and you are using that weight to find out the total price on day 2 and day 4. So for day 2, we have a sub 2 as 250. So the total price would actually be 250 times 5, which is $1,250. And a sub 4 is 62.5. So we're going to use 62.5 times $25 per milligram. And that will give us a total of 1,562.5. So of course, day 4 is better, because that will earn us more money. That is example 2. Should be fairly straightforward. Now let's look at example 3 and 4, which is slightly different. Number 3, a salesperson took over a sales route that has 17 customers. She is adding 2 customers every month. So let's think about this. Even though we have the information, but adding 2 customers. The person took over the sales route. So before the person even worked for 1 day or 1 week or 1 month, she already had 17 customers, which means not after the first month that she had 17 customers. It's at the very beginning of the first month. So that means we can't have a sub 1 as 17. 17 is in fact our a sub 0 because that even happened before we have the first month passed. So a sub 0 is 17, we add 2. So after the first month, there will be 19 customers, and after the second month, add another 2, 21, and a sub 3, 23. Keep on going. So in this case, you can see we're adding 2 in between. That means our common difference is 2. Sequence type, arithmetic, and function is linear. Our a sub 1 is 19, and a sub n equals a sub n minus 1 plus 2. Explicit formula, a sub n equals 19 plus n minus 1 times 2, which is 19 plus 2n minus 2. And that is going to be simplified as 2n plus 17. And if you haven't noticed, well, this part of the minus 2 is basically like we're going backwards to actually do a minus 2. That's why inside our explicit formula for arithmetic sequence, it's always going to be our a sub 0 that's actually in the formula. The question, how many customers will she have 1 year after she took over the route? 1 year is 12 a month, since we're counting monthly. So we're basically looking for a sub 12. Remember, we're using sequence notation to represent it. And that is going to be 2 times 12 minus 17, which is, well, not minus, plus 17, which is going to be 41. Don't forget the unit, which is customers. That is example 3. Next, the last one, example 4. Fidget spinners used to be so popular, the price went up 15% every week. Spinners originally cost $3. So same idea, before you even start selling it, before the price even go up after the first week, it's already costing $3. That means 3 is actually our a sub 1. I mean a sub 0 as 3. Next, it went up 15%. Let's say this is the original price, which is 100%. And you add onto an extra part, which is the 15%. So in total, you would actually have 115%, which can be changed into decimal as 1.15. So it's actually basically the new price is 1.15 of the original price. We are multiplying 1.15 to get the next one, and that will give us a sub 1 as 3.45. And then we're going to multiply by another 1.15, and that is going to give us a sub 2 as 3.97. And you can keep on finding more. We can pause there. Just for you to understand, if I say the price went down, let's say 10%, that means it's going to be 100%. Then you're subtracting this, so that is, the whole thing is 100%. And then you're subtracting this 10%. The rest is going to be 90%, which is 0.9 in decimal. So just make sure you understand about the markup and markdown. Since we're multiplying, it's got to be a common ratio, geometric, exponential. A sub 1 is not 3.45. And my a sub n is a sub n minus 1 times 1.15. Explicit formula, a sub n equals 3.45 times 1.15 to the n minus 1 power. How much would a spinner cost after 10 weeks? That means we're looking for a sub 10. So 3.45 times 1.15 to the 10 minus 1 power, which is basically to the 9th power. That is going to give us $12.14. Some of you might be like, wait, but 115% is basically like 23 over 20. That's fine, but this, I know I've suggested us to actually keep fractions because they're more precise. That is still right. There's only one exception, is when we work with money. Because we will almost never say to someone, hey, here's 1/5 of a dollar. We will actually tell them here's 20 cents, or here's like 2 something. But we will never use fractions to describe money. So whenever we're working with money, we'll always keep the decimals and also round to 2 decimal places. That's example 4. That is everything for 6.9. Thank you.